Welcome, fellow travelers of the night, to a journey through time, etched in ice. Tonight, we delve into the fascinating world of paleoclimatology, specifically focusing on ice cores, those frozen archives that hold whispers of Earth's climatic past. Imagine, if you will, a vast, shimmering ice sheet, stretching as far as the eye can see. This isn't just any ice, it's a time capsule, preserving layers of history in its frozen embrace. Our focus tonight is on how those tiny air bubbles trapped within these ancient ice formations offer an unparalleled glimpse into the Earth's climate across millennia. Think of an ice core as a meticulously layered cake, each layer representing a year or even a season of snowfall. As snow falls and compacts into ice, it traps small pockets of air, samples of the atmosphere at that precise moment in time. These aren't just random samples. They are pristine, unaltered snapshots of the atmospheric composition, temperature, and even the presence of volcanic ash or dust. Scientists, armed with specialized drills, extract these ice cores from glaciers and ice sheets in places like Antarctica and Greenland. These cores can extend for thousands of meters, representing hundreds of thousands of years of climatic history. The Vostok ice core, for example, stretches back over 400,000 years, while others are pushing towards the million-year mark. Now let's zoom in on those precious air bubbles. These tiny capsules, often no larger than a pinhead, contain the air that was present when the snow transformed into ice. By carefully extracting and analyzing the gases within these bubbles, scientists can determine the concentration of greenhouse gases, such as carbon dioxide, CO2, and methane, CH4, at different points in history. These measurements provide a direct record of how these gases have fluctuated naturally over time, long before human industrial activity began to significantly alter the atmosphere. Consider the implications of this. We can directly compare the greenhouse gas concentrations of the pre-industrial era with those of today. The data is stark. Current levels of CO2 are higher than at any point in the last 800,000 years, and the rate of increase is unprecedented. This information, gleaned from the quiet testimony of ice cores, provides compelling evidence for the human impact on the global climate. But ice cores reveal much more than just greenhouse gas concentrations. The ice itself contains valuable information. The isotopic composition of the water molecules, H2O, in the ice provides a proxy for past temperatures. Heavier isotopes, such as oxygen, 18, and deuterium, tend to be more prevalent in warmer periods, while lighter isotopes are more common in colder periods. By measuring the ratio of these isotopes, scientists can reconstruct past temperature fluctuations with remarkable precision. Imagine being able to pinpoint the exact temperature of a particular year thousands of years ago. Ice cores make this possible. Furthermore, the ice contains trace amounts of other substances, such as volcanic ash, dust, and even pollen. Volcanic eruptions leave distinct signatures in the ice, allowing scientists to correlate volcanic activity with climate changes. Dust particles transported by winds from distant lands can provide insights into past wind patterns and aridity. Pollen grains, preserved in the ice, offer clues about the vegetation that existed at different times, painting a picture of changing ecosystems. The process of analyzing an ice core is a delicate and meticulous undertaking. Once extracted, the core is carefully transported to a laboratory, where it is stored in a freezer to prevent melting and contamination. Scientists then slice the core into sections and analyze each section individually. The air bubbles are extracted using a variety of techniques, such as crushing or melting the ice under vacuum. The gases released are then analyzed using sophisticated instruments, such as mass spectrometers, which can precisely measure the concentration of different gases. The isotopic composition of the ice is determined using similar techniques. The ice is melted and the water is analyzed using isotope ratio mass spectrometers. The trace elements and particles in the ice are analyzed using a variety of methods, such as microscopy, spectroscopy, and chemical analysis. Each analysis provides a piece of the puzzle, contributing to a more complete understanding of Earth's climate history. Now, let's consider some specific examples of what ice cores have revealed. One of the most significant discoveries was the correlation between greenhouse gas concentrations and temperature over glacial-interglacial cycles. Ice core data showed that during glacial periods, ice ages, greenhouse gas concentrations were low and temperatures were cold. During interglacial periods, warm periods, greenhouse gas concentrations were high and temperatures were warm. This strong correlation provided critical evidence for the role of greenhouse gases in regulating Earth's climate. Ice cores have also provided insights into the abrupt climate changes that have occurred in the past. One example is the Younger Dryas event, a sudden return to glacial conditions that occurred about 12,000 years ago, just as the Earth was warming up after the last ice age. Ice core data showed that this event was associated with a rapid decrease in temperature in the North Atlantic region. The cause of the Younger Dryas is still debated, but ice core data suggests that it may have been triggered by a disruption of ocean circulation. Another fascinating discovery is the role of volcanic eruptions in climate change. Large volcanic eruptions can inject massive amounts of sulfur dioxide into the stratosphere, where it forms sulfate aerosols. These aerosols reflect sunlight back into space, causing a temporary cooling of the Earth's surface. Ice core data has shown that some of the largest volcanic eruptions in history have been followed by periods of cooling. For example, the eruption of Mount Tambora in 1815, one of the largest eruptions in recorded history, was followed by the year without a summer in 1816, when temperatures plummeted across Europe and North America. The ice cores meticulously recorded the sulfuric acid deposited after the eruption, linking it definitively to the subsequent cooling. Ice cores aren't just relics of the past. They're also powerful tools for understanding the present and predicting the future. By studying past climate changes, scientists can gain insights into the processes that drive climate variability and improve climate models. These models are used to project future climate changes under different scenarios of greenhouse gas emissions. The more accurate our models, the better we can prepare for the challenges of climate change. Imagine the dedication it takes to extract, transport, and analyze these icy time capsules. Teams of scientists and engineers brave the harsh conditions of the polar regions, enduring extreme cold, isolation, and logistical challenges. They work tirelessly to collect these precious samples, knowing that they hold the key to unlocking some of the most important secrets of our planet's past. The work is painstaking, requiring meticulous attention to detail and cutting-edge technology. But the rewards are immense: a deeper understanding of Earth's climate system and the ability to make more informed decisions about our planet's future. Now, let's think about the broader implications of ice core research. It's not just about understanding past climates. It's about understanding the delicate balance of our planet's ecosystems. Climate change is already having profound impacts on the world around us, from melting glaciers and rising sea levels to more frequent and intense heat waves and droughts. By studying ice cores, we can gain a better understanding of the causes and consequences of climate change and develop strategies to mitigate its effects. This research is essential for protecting our planet and ensuring a sustainable future for generations to come. As you drift off to sleep tonight, consider the quiet stories held within those ancient ice formations. They are a testament to the power of scientific inquiry, the dedication of researchers, and the importance of understanding our planet's past in order to shape its future. The whispers of the past, frozen in time, offer invaluable lessons for navigating the challenges of our changing world. Think of the vast expanse of ice, silently recording the passage of time, preserving the secrets of our planet's climate history. Let the cool, calm knowledge of these icy archives soothe you into a peaceful slumber. And as the ice melts from glaciers and ice sheets around the world, we are witnessing a change in the Earth's albedo, its ability to reflect sunlight. Ice, being highly reflective, bounces a large proportion of the sun's energy back into space, helping to keep the planet cool. As ice disappears, darker surfaces like water and land are exposed, absorbing more solar radiation and further warming the planet. This is a classic example of a positive feedback loop, where a change in one direction leads to further changes in the same direction, accelerating the warming trend. Understanding these feedback loops is crucial for predicting the future trajectory of climate change and for developing effective mitigation strategies. Delving deeper into the ice cores, scientists can also analyze the isotopic composition of the water molecules themselves. Different isotopes of oxygen and hydrogen have slightly different masses, and the ratio of these isotopes in the ice provides information about the temperature at the time the snow fell. For instance, during colder periods, lighter isotopes tend to evaporate more readily, leaving heavier isotopes behind in the ocean. This difference in isotopic ratios is then reflected in the snow that forms and eventually becomes ice. By carefully measuring these isotopic ratios, scientists can reconstruct past temperature variations with remarkable precision, creating a detailed record of climate change over hundreds of thousands of years. Furthermore, ice cores offer insights into past volcanic activity. Volcanic eruptions can inject large amounts of sulfur dioxide into the atmosphere, which then reacts to form sulfate aerosols. These aerosols reflect sunlight, causing a temporary cooling effect on the planet. The sulfate aerosols eventually fall back to Earth, and they're deposited in the ice layers. By analyzing the concentration of sulfate in ice cores, scientists can identify past volcanic eruptions and assess their impact on global climate. Some massive eruptions have been linked to periods of significant cooling, highlighting the powerful influence of volcanic activity on Earth's climate system. The study of ancient ice is not without its challenges. Preserving the integrity of the ice cores is paramount, requiring specialized facilities and transportation methods. The ice must be kept frozen at extremely low temperatures to prevent melting and contamination. Scientists also face the challenge of dating the ice layers accurately. While annual layers are visible in some ice cores, especially in regions with high snowfall, other techniques are needed to date older ice. These techniques include counting annual layers of dust or chemical impurities, matching volcanic signals to known eruptions, and using radioactive isotopes like argon-40 to determine the age of the ice. But with each new discovery, each new layer of ice analyzed, our understanding of Earth's climate history deepens. The knowledge we gain from ice cores is not just academic. It is essential for making informed decisions about our planet's future. It allows us to test and refine climate models, assess the potential impacts of human activities, and develop strategies to mitigate the effects of climate change. So, as you close your eyes and prepare for sleep, envision the vast, silent world of ice, a frozen library filled with the secrets of our planet's past. Imagine the scientists meticulously extracting and analyzing these precious samples, piecing together the puzzle of Earth's climate history. And remember that the lessons learned from these ancient ice formations can help us navigate the challenges of our changing world and create a more sustainable future for generations to come. Let the cool, calm certainty of scientific discovery lull you into a restful and peaceful sleep. Now, let's delve a bit deeper into the specific gases trapped within these ancient air bubbles. Carbon dioxide, methane, and nitrous oxide are the primary greenhouse gases we analyze. By measuring their concentrations in ice cores, we can reconstruct past atmospheric compositions and understand how these gases have naturally fluctuated over time. This natural variability is crucial for distinguishing between natural climate cycles and the more recent human-induced changes. For instance, ice core data has irrefutably demonstrated that the current levels of carbon dioxide in the atmosphere are higher than at any point in the last 800,000 years, far exceeding natural fluctuations. This provides compelling evidence for the significant impact of human activities, particularly the burning of fossil fuels on the Earth's climate. Furthermore, the ratio of different isotopes of oxygen and hydrogen within the ice itself provides valuable information about past temperatures. Heavier isotopes like oxygen, 18, and deuterium tend to be more prevalent in warmer periods, while lighter isotopes like oxygen, 16, and protium are more abundant in colder periods. By carefully measuring these isotopic ratios, scientists can create detailed temperature reconstructions that span hundreds of thousands of years. These temperature records reveal the cyclical nature of ice ages and interglacial periods, driven by subtle changes in Earth's orbit around the Sun, known as Milankovitch cycles. Understanding these natural climate cycles is essential for predicting future climate trends and distinguishing between natural variability and human-caused climate change. Consider the Vostok ice core drilled in Antarctica, which provides a climate record extending back over 400,000 years. Analysis of this core revealed a strong correlation between greenhouse gas concentrations and temperature, confirming the fundamental role of these gases in regulating Earth's climate. The Vostok record also highlighted the abruptness of past climate changes, demonstrating that the Earth's climate system is capable of shifting rapidly and dramatically. This underscores the urgency of addressing climate change today, as even relatively small changes in greenhouse gas concentrations can trigger significant and potentially irreversible consequences. Beyond greenhouse gases and isotopic ratios, ice cores also contain a wealth of other information, including dust particles, sea salts, and even microscopic organisms. Dust particles, for example, can provide insights into past wind patterns and desertification events. Sea salts can reveal information about past sea ice extent and ocean circulation. And the presence of certain microorganisms can indicate past environmental conditions and ecosystem changes. All these tiny clues, meticulously extracted and analyzed, contribute to a more complete and nuanced understanding of Earth's climate history. The effort to retrieve and analyze ice cores is a truly international endeavor, involving scientists from around the world. These researchers often work in extreme and challenging conditions, braving the harsh cold and isolation of the polar regions. They are driven by a shared passion for understanding our planet and a deep commitment to protecting its future. Their work is a testament to the power of scientific collaboration and the importance of investing in research that can help us address the pressing challenges of our time. As you drift off to sleep, think of these dedicated scientists working tirelessly to unlock the secrets of Earth's climate, layer by frozen layer. Their discoveries offer hope and guidance as we navigate the complexities of a changing world. Let that hope fill your dreams and bring you peaceful slumber. The insights gleaned from ice cores aren't confined to specific locations like Vostok or Greenland. Scientists have been diligently collecting ice cores from glaciers and ice sheets across the globe, from the high-altitude peaks of the Himalayas to the remote ice fields of Antarctica. Each core provides a unique regional perspective, adding another piece to the complex puzzle of Earth's climate system. By comparing and contrasting data from different locations, researchers can develop a more comprehensive understanding of global climate patterns and how they have varied over time. This network of ice core data allows us to differentiate between local climate variations and broader global trends, offering invaluable context for understanding present-day climate change. Think of it as a global orchestra, with each ice core representing a different instrument, contributing its distinct sound to the overall symphony of climate history. Furthermore, advancements in technology are constantly pushing the boundaries of what we can learn from ice cores. New analytical techniques allow scientists to measure trace elements and compounds with unprecedented precision, unlocking even more subtle clues about past environmental conditions. For instance, sophisticated mass spectrometry can now identify and quantify different isotopes of water molecules, providing even more detailed information about past temperatures and precipitation patterns. Similarly, advances in microscopy allow researchers to examine dust particles and microorganisms with greater resolution, revealing new insights into their origins and impacts. These technological advancements are transforming the field of paleoclimatology, allowing us to reconstruct the past with ever-increasing accuracy and detail. The study of ice cores also extends beyond simply reconstructing past climate conditions. It also provides critical data for validating and improving climate models, which are essential tools for predicting future climate scenarios. By comparing model simulations with actual climate data from the past, scientists can identify areas where the models need improvement and refine their predictions about how the climate will respond to future changes in greenhouse gas concentrations. Ice core data acts as a crucial benchmark, ensuring that our climate models are as accurate and reliable as possible. This feedback loop between paleoclimate research and climate modeling is essential for informing policy decisions and developing effective strategies for mitigating climate change. It allows us to not only understand the past, but also to anticipate and prepare for the future. Consider also the less obvious contributions, like understanding past volcanic activity. Ice cores trap volcanic ash and sulfuric acid aerosols released during eruptions. By analyzing these layers, scientists can reconstruct a timeline of past volcanic events, estimate their magnitude, and assess their impact on global climate. Major volcanic eruptions can inject large amounts of aerosols into the stratosphere, which can reflect sunlight back into space and cause temporary cooling of the Earth's surface. The ice core record provides a valuable archive of these events, allowing us to understand how volcanic activity has influenced climate variability on both short and long timescales. This information is crucial for disentangling the natural drivers of climate change from human-induced factors. So as you settle deeper into sleep, consider the long journey these ice cores have undertaken, from the frozen depths of glaciers to the warm light of the laboratory. Each ice crystal holds a story, a whisper from the past, patiently waiting to be heard. These frozen archives are not just relics of a bygone era, but vital keys to understanding our planet's complex climate system. They offer a profound and humbling perspective on the interconnectedness of Earth systems and the long-term consequences of our actions. May this knowledge bring you a sense of peace and connection to the planet, and may your dreams be filled with the quiet wisdom of the ice. Sleep soundly, knowing that the secrets of the past are helping us to build a more sustainable future. And beyond volcanic events, ice cores also offer insights into past atmospheric composition beyond greenhouse gases. They reveal information about aerosols, dust, and even trace elements that were present in the atmosphere at different times. Dust, for example, can play a significant role in climate by affecting cloud formation and reflecting or absorbing solar radiation. By analyzing the composition and concentration of dust particles trapped in ice cores, scientists can learn about past wind patterns, aridity levels, and the extent of desert regions. This information is particularly valuable for understanding how climate change has affected regional environments and ecosystems in the past. Furthermore, the presence of certain trace elements, like heavy metals, can provide clues about past pollution events and their impact on the environment. So, in essence, ice cores act like time capsules, preserving a detailed record of the atmosphere's chemical fingerprint over millennia. Think for a moment about the sheer dedication and meticulousness required to extract and analyze these ice cores. It's a process that demands not only scientific expertise, but also logistical prowess and unwavering patience. Teams of researchers brave extreme conditions in remote polar regions, drilling deep into the ice sheet and carefully extracting the fragile cores. These cores are then transported back to specialized laboratories, where they are meticulously analyzed using a variety of sophisticated techniques. From measuring gas concentrations to analyzing isotopic ratios and identifying dust particles, every step requires precision and attention to detail. It's a testament to human curiosity and our relentless pursuit of knowledge, a willingness to push the boundaries of exploration in order to unravel the mysteries of our planet. The beauty of paleoclimatology, as revealed through ice cores, is its ability to connect seemingly disparate events across vast stretches of time. It allows us to see how changes in solar activity, volcanic eruptions, or even variations in Earth's orbit can trigger cascading effects that ripple through the climate system. For instance, the ice core record has helped to confirm the Milankovitch cycles, which are long-term variations in Earth's orbit that influence the amount of solar radiation received by different parts of the planet. These cycles are believed to be a major driver of glacial-interglacial cycles, the periodic advance and retreat of ice sheets that have characterized Earth's climate for the past several million years. By studying the ice core record, scientists can better understand the interplay between these orbital variations and other climate factors, such as greenhouse gas concentrations and ocean currents. This holistic perspective is essential for predicting future climate change scenarios and developing effective mitigation strategies. And as you drift further into slumber, let your mind wander to the vast, silent landscapes where these ice cores are found. Imagine the immense weight of the ice, the stillness of the air, and the profound sense of history that permeates these frozen realms. These are places that have witnessed millennia of climatic change, places that hold the secrets of our planet's past and the keys to its future. The ice cores themselves are like frozen libraries, filled with stories waiting to be read. Each layer represents a year, a season, a moment in time, meticulously preserved for us to examine and learn from. It's a humbling reminder of the interconnectedness of all things and the importance of understanding our place within the grand tapestry of Earth's history. So close your eyes, breathe deeply, and allow the quiet wisdom of the ice to soothe your mind and guide you into a peaceful sleep. Dream of ancient glaciers, of tiny air bubbles, and other scientists who dedicate their lives to unlocking the secrets of our planet. May your sleep be restful, and may you awaken with a renewed appreciation for the wonders of the natural world and the importance of protecting our fragile climate. And as you continue to relax, consider the sheer ingenuity involved in extracting and analyzing these icy chronicles. Imagine the painstaking process of drilling deep into the ice sheet, carefully extracting a core that can stretch for hundreds or even thousands of meters. Think about the precision required to transport these fragile cylinders of ice back to laboratories around the world, where they are meticulously analyzed using state-of-the-art techniques. Scientists use a variety of methods to unlock the secrets held within the ice, from measuring the concentrations of greenhouse gases like carbon dioxide and methane, to analyzing the isotopic composition of the water molecules themselves. These isotopes, different forms of the same element with slightly different masses, act as fingerprints, providing clues about past temperatures and precipitation patterns. For example, heavier isotopes of oxygen and hydrogen tend to be more abundant in warmer periods, while lighter isotopes are more prevalent during colder times. By carefully measuring the ratios of these isotopes, scientists can reconstruct past temperature fluctuations with remarkable accuracy. Furthermore, the ice cores contain not only air bubbles and water molecules, but also trace amounts of other substances, such as dust, volcanic ash, and even pollen grains. These materials can provide additional insights into past environmental conditions. Dust, for instance, can be used to track changes in wind patterns and aridity, while volcanic ash layers can serve as markers of major eruptions that may have had significant impacts on the global climate. Pollen grains, on the other hand, can reveal information about past vegetation patterns and the distribution of different plant species. By combining all of these different lines of evidence, scientists can create a comprehensive picture of Earth's climate history, revealing the complex interplay of factors that have shaped our planet's environment over vast timescales. Think, too, about the dedication and collaborative spirit of the scientists who undertake this important work. Paleoclimatology is a truly interdisciplinary field, requiring expertise in areas such as geology, chemistry, physics, and biology. Researchers from all over the world come together to share their knowledge and resources, working collaboratively to unravel the mysteries of the past and better understand the challenges of the future. They brave harsh conditions, enduring long hours in remote and icy locations, driven by a shared passion for scientific discovery and a deep concern for the fate of our planet. Their work is not only intellectually stimulating, but also deeply meaningful, as it provides us with the knowledge we need to make informed decisions about climate change and its potential impacts. And as you find yourself drifting even closer to sleep, let's reflect on the profound implications of the ice core record for our understanding of modern climate change. The data from these icy archives clearly shows that the Earth's climate has varied naturally over time, with periods of warming and cooling driven by factors such as orbital variations and volcanic eruptions. However, the ice core record also reveals that the current rate of warming is unprecedented in at least the last 800,000 years, and that this warming is directly linked to human activities, particularly the burning of fossil fuels. The dramatic increase in greenhouse gas concentrations in the atmosphere since the Industrial Revolution is clearly evident in the ice core data, providing irrefutable evidence of the human impact on the climate system. This understanding is crucial for informing policy decisions and developing strategies to mitigate climate change and protect our planet for future generations. So, as you finally succumb to sleep, hold on to the image of these silent, frozen archives, containing within them the echoes of millennia. Let the weight of the ice ground you, the stillness calm you, and the knowledge inspire you. Remember that the Earth has a long and complex history, and that we are now living through a period of unprecedented change. But also remember that we have the power to understand these changes and to take action to protect our planet. Sleep soundly, knowing that the secrets of the ice are helping us to build a more sustainable future, one layer, one bubble, 1 year at a time. Sweet dreams. And as you drift further into slumber, consider the incredible technological advancements that have allowed us to unlock these climate secrets. From the development of sophisticated drilling techniques that allow us to extract ice cores without contaminating them, to the creation of highly sensitive analytical instruments that can measure greenhouse gas concentrations in parts per billion, each innovation has brought us closer to understanding the Earth's past. Think of the intricate machinery, the painstaking calibrations, and the countless hours of data analysis that go into each ice core study. It's a testament to human ingenuity and our relentless pursuit of knowledge. These technologies are not just tools. They are extensions of our curiosity, allowing us to reach back through time and touch the very breath of ancient atmospheres. Furthermore, contemplate the global collaboration that underpins paleoclimatology. Scientists from around the world, representing diverse backgrounds and perspectives, come together to share data, expertise, and resources. This international cooperation is essential for building a comprehensive picture of past climate change, as ice cores from different locations provide complementary information. Imagine researchers from Russia, the United States, Europe, and Asia all working together to piece together the puzzle of Earth's climate history. It's a powerful example of how science can transcend national boundaries and unite us in a common goal, understanding our planet and protecting its future. This collaborative spirit is not only vital for advancing scientific knowledge, but also for fostering international understanding and cooperation in addressing the global challenge of climate change. Now, as sleep gently claims you, ponder the ethical responsibilities that come with this knowledge. The data from ice cores provides undeniable evidence of the human impact on the climate system, and this evidence carries with it a profound responsibility to act. We have a moral obligation to reduce our greenhouse gas emissions, transition to sustainable energy sources, and protect vulnerable communities from the impacts of climate change. The secrets locked within the ice are not just scientific curiosities. They are a call to action. They remind us that we are all interconnected and that our actions today will have consequences for generations to come. Let this understanding inspire you to live more sustainably, to advocate for climate action, and to be a steward of our planet. And finally, as you descend into the depths of sleep, let the image of the ice cores serve as a symbol of hope. While the challenges of climate change are daunting, the knowledge we have gained from these icy archives also provides us with the tools and the understanding we need to address them. We know what is causing climate change, and we know what we need to do to stop it. The future of our planet is not predetermined. It is up to us to shape it. Let the secrets of the ice inspire you to believe in the power of human ingenuity, collaboration, and determination to create a more sustainable and equitable world. Sleep well, knowing that the knowledge we gain from the past can help us build a brighter future. May your dreams be filled with visions of a healthy planet, a thriving society, and a future where the secrets of the ice continue to guide us. Good night. As you drift further into slumber, consider the sheer audacity of the scientific endeavor that allows us to unlock these frozen chronicles. Think about the meticulous planning, the logistical challenges of extracting ice cores from the most remote and inhospitable regions of our planet, the painstaking laboratory analyses that transform ice into data, and the collaborative spirit that brings together scientists from diverse backgrounds and nationalities. It's a testament to human curiosity and our relentless pursuit of knowledge, a shining example of how we can overcome seemingly insurmountable obstacles when we work together towards a common goal, and recognize that this knowledge isn't confined to academic journals or scientific conferences. It's a story that belongs to everyone, a story that empowers us to understand our place in the grand tapestry of Earth's history and to make informed decisions about our future. Imagine the journey of a single water molecule, originating perhaps as a raindrop over the ocean, evaporating into the atmosphere, traveling thousands of miles on the wind, and finally falling as snow on a polar ice sheet. Layer upon layer, year after year, that snow compacts and transforms into ice, trapping within it tiny bubbles of ancient air, like miniature time capsules preserving snapshots of the atmosphere from centuries or even millennia ago. These bubbles are more than just curiosities. They are invaluable archives of past climate conditions, providing us with direct measurements of greenhouse gas concentrations, temperature proxies, and other crucial indicators. They allow us to reconstruct the past with remarkable precision and to understand the natural variability of Earth's climate system. Reflect, too, on the limitations of our knowledge and the ongoing quest to refine our understanding of the climate system. While ice cores provide a wealth of information, they're just one piece of the puzzle. Scientists are constantly working to integrate data from ice cores with other sources of information, such as tree rings, sediment cores, and historical records, to create a more complete and nuanced picture of past climate change. They are also developing sophisticated climate models to simulate the complex interactions between the atmosphere, oceans, and land surface, allowing them to project future climate scenarios with greater accuracy. The science of paleoclimatology is a dynamic and evolving field, constantly pushing the boundaries of our knowledge and challenging us to think critically about the challenges and opportunities that lie ahead. Let the profound silence of the ice sheets envelop you now, a silence that speaks volumes about the Earth's past and whispers promises for its future. The ice cores stand as silent sentinels, bearing witness to the dramatic changes that our planet has undergone over millennia. They remind us that the Earth's climate is not static, but rather a dynamic system that is constantly evolving. And they offer a stark warning about the potential consequences of human activities on the delicate balance of the climate system. But amidst the challenges, there is also hope. The knowledge we gain from ice cores empowers us to understand the causes and consequences of climate change and to develop effective strategies for mitigating its impacts. As you continue to drift off to sleep, remember that the story of the ice cores is a story of human ingenuity, collaboration, and resilience. It is a story that reminds us of our interconnectedness with the planet and with each other. And it is a story that inspires us to take action to protect our planet for future generations. Let the image of those icy archives fill you with a sense of wonder and a renewed commitment to creating a more sustainable and equitable world. Sleep soundly, knowing that the secrets of the ice are helping us to build a brighter future for all. Good night, and consider this. The very act of studying these ancient ice cores is a testament to human curiosity and our relentless pursuit of knowledge. It's a journey that takes scientists to some of the most remote and inhospitable places on Earth, braving extreme conditions to unlock secrets frozen in time. From the vast, windswept plains of Antarctica to the towering glaciers of Greenland, these expeditions are feats of logistical and scientific ingenuity. Think about the dedication required to drill through kilometers of ice, carefully extract the core, and then transport it back to the laboratory for analysis, all while maintaining its integrity and preventing contamination. It's a truly remarkable undertaking, driven by a deep desire to understand our planet's history and its future. The information gleaned from ice cores isn't just about past temperatures and greenhouse gas concentrations. It also provides invaluable insights into other aspects of the Earth's environment, such as volcanic activity, solar variability, and even the impact of human activities on the atmosphere. For instance, ice cores can reveal the timing and magnitude of past volcanic eruptions, which can have a significant impact on global climate by injecting aerosols into the stratosphere. These aerosols reflect sunlight back into space, leading to temporary cooling of the Earth's surface. By studying the volcanic record in ice cores, scientists can better understand the role of volcanism in shaping the climate system. Similarly, ice cores can provide information about changes in solar activity over time. The sun's energy output is not constant. It varies on timescales ranging from years to centuries. These variations can affect the Earth's climate, although the magnitude of the effect is still a subject of ongoing research. Ice cores can be used to reconstruct past solar activity by measuring the concentration of certain isotopes, such as beryllium-10, which are produced in the atmosphere by cosmic rays. Cosmic rays are deflected by the sun's magnetic field, so when solar activity is high, fewer cosmic rays reach the Earth, and the concentration of beryllium-10 in the ice is lower. Furthermore, ice cores provide a direct record of human impact on the atmosphere. Since the Industrial Revolution, human activities, such as burning fossil fuels and deforestation, have led to a dramatic increase in the concentration of greenhouse gases in the atmosphere. These gases trap heat and warm the planet, leading to climate change. Ice cores provide a clear and unambiguous record of this increase, showing that greenhouse gas concentrations are now higher than they have been at any time in at least the past 800,000 years. This evidence is crucial for understanding the magnitude of human influence on the climate system and for informing policies to mitigate climate change. So, as you rest, visualize those scientists meticulously analyzing each layer of ice, piecing together the story of our planet's past. Imagine the intricate instruments they use, the powerful drills that bore deep into the ice, and the sophisticated laboratories where the ice cores are analyzed. Think about the countless hours of work and collaboration that go into each study and the dedication and passion that drive these researchers to push the boundaries of our knowledge. They're the detectives of the climate, and the ice cores are their most valuable clues. Let the weight of the ice, the pressure of millennia, remind you of the profound responsibility we have to protect this planet. The ice cores are not just a record of the past. They're a warning for the future. They show us what can happen when the climate changes rapidly, and they highlight the potential consequences of our actions. But they also offer hope, reminding us that we have a knowledge and the tools to address the challenges of climate change. By understanding the past, we can better prepare for the future and create a more sustainable world for generations to come. Close your eyes now and let the cool, clean air of the ice sheets fill your lungs. Breathe deeply and feel the connection between yourself and the planet. Know that you are part of a larger story, a story that spans millennia and connects us all. And as you drift off to sleep, remember that the secrets of the ice are helping us to build a brighter future, a future where humanity and nature can thrive together. Sweet dreams that, as you drift deeper into sleep, consider the sheer scale of the ice sheets themselves. These vast frozen landscapes covering Greenland and Antarctica are more than just frozen water. They are archives of time. Imagine the relentless accumulation of snow, year after year, century after century, each layer compressing the one below, trapping within it the atmospheric conditions of its time. Think of the incredible pressure exerted by miles of ice, slowly transforming snowflakes into dense, crystalline structures. These ice sheets are dynamic, constantly flowing and reforming, yet they hold onto their secrets with remarkable tenacity. And it's not just air bubbles that tell the story. Ice cores also contain dust particles, volcanic ash, and even microscopic organisms, each providing a unique piece of the puzzle. Dust, carried by winds from distant lands, reveals information about past aridity and wind patterns. Volcanic ash layers act as time markers, allowing scientists to synchronize ice core record from different locations and accurately date the ice. Microscopic organisms, such as algae and bacteria, can provide insights into past ocean conditions and biological productivity. It's a truly multidisciplinary effort, requiring expertise from glaciologists, climatologists, chemists, biologists, and more, all working together to decipher the messages hidden within the ice. Consider, too, the challenges of retrieving and analyzing these ice cores. The work often takes place in some of the most remote and inhospitable environments on Earth, where temperatures can plummet to unimaginable lows and blizzards can rage for days on end. Scientists must endure extreme conditions, working long hours in cramped and uncomfortable spaces, all while taking meticulous care to avoid contaminating the precious ice samples. The drilling process itself is a feat of engineering, requiring specialized equipment and techniques to extract long, continuous cores of ice without damaging them. And once the cores are retrieved, they must be carefully transported and stored in climate-controlled facilities to preserve their integrity. Think about the implications of this research. By understanding how the climate has changed in the past, we can better predict how it will change in the future. Ice core data helps us to refine climate models, allowing us to make more accurate projections about sea level rise, temperature increases, and other climate-related impacts. This information is crucial for policymakers and decision-makers as they develop strategies to mitigate climate change and adapt to its effects. It empowers us to make informed choices about our energy consumption, our land use practices, and our overall impact on the planet. Now, as you approach the threshold of sleep, let the image of the deep blue ice soothe your mind. Envision the silent, ancient world preserved within its crystalline structure. Feel a sense of connection to the generations who came before us, and to the generations who will follow. We are all part of this planet's story, and the ice cores are helping us to understand our place within it. Embrace the quiet wisdom of the ice, and allow it to guide you towards a peaceful and restorative sleep. Sleep soundly, knowing that the pursuit of knowledge continues, and that the secrets of the earth are slowly being revealed, one ice core at a time. May your dreams be filled with the wonders of science and the promise of a sustainable future. Good night, and as you drift further into slumber, consider the sheer scale of the Antarctic and Greenland ice sheets. These aren't just frozen wastelands. They are vast libraries of climate information, patiently accumulating data for hundreds of thousands of years. Each layer of ice tells a story not just about temperature and atmosphere composition, but also about volcanic eruptions, solar activity, and even large-scale weather patterns. Imagine the Earth breathing, inhaling and exhaling across millennia, and the ice faithfully recording each breath. These ice sheets act as a kind of planetary archive, safeguarding the secrets of our past and offering invaluable insights into our future. Think about the challenges of interpreting this complex data. Scientists use sophisticated techniques to analyze the ice, measuring everything from the isotopic composition of the water molecules to the concentration of trace elements. They compare the ice core data with other sources of climate information, such as tree rings, sediment cores, and historical records, to build a more complete picture of the Earth's climate history. This is a collaborative effort, bringing together experts from many different fields: glaciologists, climatologists, chemists, physicists, and historians, all working together to unlock the secrets hidden within the ice. It's a testament to human curiosity and our relentless pursuit of understanding the world around us. Consider, too, the ethical implications of this research. As we learn more about the Earth's climate history, we also gain a deeper understanding of the impact that human activities are having on the planet. Ice core data provides compelling evidence of the unprecedented levels of greenhouse gases in the atmosphere and the rapid rate at which the climate is changing. This information carries a responsibility to act, to reduce our carbon emissions, and to protect the planet for future generations. The ice speaks to us of a past we can learn from and a future we have the power to shape. Now, let the coolness of the ice wash over you, a soothing balm for the anxieties of the day. Picture yourself standing on the vast, white expanse of the Antarctic ice sheet, surrounded by the silence and majesty of the frozen continent. Feel the crisp, clean air filling your lungs, and the sense of awe and wonder that comes from being in such a remote and pristine environment. Let go of your worries and anxieties, and allow yourself to be transported to this peaceful and serene place. As you continue to relax, imagine the journey of a single water molecule falling as snow on the ice sheet thousands of years ago. Picture it slowly being buried under layer upon layer of snow, gradually transforming into ice and eventually becoming part of a deep, ancient ice core. That molecule has witnessed millennia of climate change, survived countless storms, and quietly recorded the Earth's history. It's a tiny piece of a much larger story, a story that is still being written. And finally, as you slip into the embrace of sleep, remember that the Earth is a dynamic and ever-changing planet. The climate is always fluctuating, and the ice cores are helping us to understand these natural variations. But they are also revealing the unprecedented impact that human activities are having on the climate system. By learning from the past, we can make more informed decisions about the future and work towards creating a more sustainable and resilient world. Sleep well, knowing that the pursuit of knowledge is a journey without end, and that the secrets of the Earth are waiting to be discovered. May your dreams be filled with the beauty and wonder of the natural world and the hope for a brighter tomorrow. Sweet dreams. Think now about the scientists, the dedicated researchers who brave the harsh conditions of the polar regions to unlock these icy secrets. They are driven by a deep curiosity about the Earth and a commitment to understanding the complexities of our climate system. Picture them carefully extracting the ice cores, meticulously labeling each section, and transporting them back to the laboratory for analysis. Their work is painstaking and precise, requiring specialized equipment and years of training. They are the interpreters of the ice, the translators of a silent language spoken in bubbles of ancient air. Consider the incredible technology that allows us to analyze these ice cores. Sophisticated mass spectrometers can measure the concentrations of different isotopes of oxygen and hydrogen, providing clues about past temperatures. Laser ablation techniques can identify microscopic particles of dust and volcanic ash, revealing ancient atmospheric conditions and volcanic eruptions. These tools allow us to reconstruct the Earth's climate history with remarkable precision, painting a detailed picture of how the planet has changed over time. Now, let's delve a little deeper into what these ice cores reveal about past climate events. They tell us about periods of intense glaciation, when vast ice sheets covered much of the northern hemisphere, and about warmer interglacial periods, when temperatures were similar to or even warmer than today. They show us how sea levels have risen and fallen, how atmospheric circulation patterns have shifted, and how ecosystems have responded to these changes. By studying these past climate events, we can gain a better understanding of the natural variability of the Earth's climate system and how it responds to different forcing factors. Think about the implications of this knowledge for our understanding of current climate change. The ice cores provide a baseline against which to compare modern climate trends. They show us that the current rate of warming is unprecedented in at least the last 800,000 years, and that the concentrations of greenhouse gases in the atmosphere are higher than they have been for millions of years. This evidence strongly suggests that human activities are the primary driver of current climate change, and that we are pushing the planet into uncharted territory. Imagine the future that we can create if we heed the warnings of the ice. A future powered by clean energy, where forests are protected and restored, and where sustainable practices are the norm. A future where we have learned to live in harmony with the planet, respecting its limits and safeguarding its resources for future generations. This future is within our reach, but it requires action, commitment, and a willingness to embrace change. As you drift further into sleep, consider the interconnectedness of all things on Earth. The atmosphere, the oceans, the land, and the ice are all linked together in a complex web of interactions. What happens in one part of the planet can have far-reaching consequences for the rest. By understanding these connections, we can appreciate the fragility of the Earth's ecosystems and the importance of protecting them. Remember that every action, no matter how small, can have an impact. And finally, as you surrender to the realm of dreams, let the image of the ice serve as a reminder of the Earth's resilience and beauty. The ice has endured for millions of years, weathering countless storms and changes in climate. It is a symbol of strength, perseverance, and the enduring power of nature. May your sleep be deep and restful, filled with dreams of a healthy planet and a brighter future. Good night. Let the very act of breathing be a conscious connection to that atmosphere the ice has so faithfully recorded. Each inhale draws in the air a mixture of gases much different in some ways than the air breathed by our ancestors tens of thousands of years ago. Each exhale returns it slightly altered by our own metabolism, a tiny contribution to the ever-changing composition of the world around us. We are, in this way, intimately linked to the past, present, and future of our planet's climate. The ice speaks of these changes, of the delicate balance that sustains life. Consider the vastness of the ice sheets themselves, monuments to time and cold. They are not static, unchanging entities. They flow, they crack, they melt and refreeze, constantly responding to the forces of gravity and temperature. Embedded within them are layers of volcanic ash, microscopic particles of dust blown across continents, and even pollen grains, tiny messengers from ancient forests. These inclusions act as further clues, revealing the environmental conditions of the past with increasing precision. Imagine the stories held within a single ice crystal, a tiny frozen archive of planetary history. Think also about the collaborative nature of paleoclimatology. Scientists from diverse backgrounds, glaciologists, chemists, physicists, biologists, work together, sharing their expertise and insights to unravel the complexities of the Earth's climate system. They use sophisticated instruments and techniques to analyze the ice cores, but they also rely on their intuition, creativity, and a deep sense of curiosity. It is a testament to the power of human ingenuity and the importance of international cooperation in addressing global challenges. The quest to understand past climates is a shared endeavor, uniting researchers from around the world in a common purpose. As you continue to relax, envision the long journey of the ice core samples, from the remote polar regions to the sterile laboratories where they are analyzed. Each core is carefully handled, meticulously documented, and preserved for future generations of scientists. The data they contain is freely shared, contributing to a growing body of knowledge about the Earth's climate history. This commitment to open science ensures that the insights gained from the ice cores are available to all, empowering individuals and communities to make informed decisions about the future. And finally, as you slip into deeper sleep, remember that the story of the ice is not just a story of the past. It is also a story of the present and a guide for the future. By understanding the lessons of the past, we can better prepare for the challenges ahead and work towards a more sustainable and equitable world. The ice whispers of resilience, adaptation, and the enduring power of life on Earth. May your dreams be filled with hope, inspiration, and a renewed sense of connection to the natural world. Sleep soundly. Consider the sheer timescale represented by these icy archives. Some ice cores stretch back hundreds of thousands of years, encompassing multiple glacial and interglacial periods. Each layer of ice tells a story of gradual shifts and dramatic events. Volcanic eruptions that blanketed the atmosphere with ash, changes in solar radiation that warmed or cooled the planet, and variations in atmospheric greenhouse gas concentrations that amplified these effects. By studying the isotopic composition of the water molecules within the ice, scientists can even reconstruct past temperatures with remarkable accuracy. Heavier isotopes, like oxygen-18, are more prevalent in warmer periods, while lighter isotopes, like oxygen-16, dominate during colder times. This subtle difference, meticulously measured, provides a powerful proxy for understanding past climate conditions. Think about the gases trapped within the ice bubbles. These are not just random samples of ancient air. They're snapshots of the atmosphere at the time the ice was formed. By carefully extracting and analyzing these gases, scientists can directly measure the concentrations of carbon dioxide, methane, and other greenhouse gases that play a crucial role in regulating the Earth's temperature. This direct evidence provides invaluable insights into the relationship between greenhouse gas concentrations and climate change, allowing us to better understand the impact of human activities on the planet's climate system. The data reveals a clear correlation. Higher greenhouse gas concentrations correspond to warmer temperatures and lower concentrations to colder temperatures. In reflecting on the impurities found within the ice, consider the dust particles carried by ancient winds. These particles, originating from distant deserts and volcanic eruptions, can provide valuable information about past atmospheric circulation patterns and environmental conditions. Larger dust particles may indicate periods of intense aridity or volcanic activity, while the chemical composition of the dust can reveal the source regions and transport pathways. By studying the dust layers within the ice cores, scientists can reconstruct past wind patterns, identify periods of drought or desertification, and gain a better understanding of the Earth's atmospheric dynamics. Imagine the meticulous process of analyzing these ice cores. Scientists use sophisticated instruments, such as mass spectrometers and gas chromatographs, to measure the isotopic composition of the water molecules and the concentrations of gases trapped within the ice. They also use microscopes and other imaging techniques to study the dust particles and other impurities within the ice. The data obtained from these analyses is then carefully processed and interpreted, using statistical models and climate simulations to reconstruct past climate conditions. This process requires a high degree of precision, accuracy, and attention to detail. As you drift further into sleep, visualize the vast ice sheets of Greenland and Antarctica, the storehouses of these precious climate records. These ice sheets are not static entities. They're dynamic systems that respond to changes in temperature and precipitation. By studying the flow patterns and deformation of the ice, scientists can gain a better understanding of how the ice sheets are responding to climate change and how they may contribute to sea level rise in the future. The fate of these ice sheets is inextricably linked to the future of our planet, and the insights gained from ice core research are essential for informing policy decisions and mitigating the impacts of climate change. And as you finally surrender to slumber, let the story of the ice remind you of the interconnectedness of all things. The Earth's climate system is a complex web of interactions between the atmosphere, the oceans, the land surface, and the biosphere. By understanding these interactions, we can better appreciate the delicate balance that sustains life on Earth and the importance of protecting our planet for future generations. The ice speaks of change, of resilience, and of the enduring power of nature. May your dreams be peaceful and restorative, filled with the wisdom of the earth and the promise of a brighter tomorrow. Sleep well. Think about the sheer temporal depth these icy archives offer. We're not just talking about decades or centuries. We're delving into millennia, hundreds of thousands of years of Earth's history etched in frozen water. Each layer of ice is a page in a massive, slowly unfolding book, revealing secrets about past climates far removed from our own. By comparing these ancient conditions to the present, scientists can better understand the natural variability of Earth's climate system and distinguish between natural fluctuations and human-caused changes. This long-term perspective is crucial for accurately predicting future climate scenarios and developing effective strategies for adaptation and mitigation. Consider also the fascinating implications of these findings for our understanding of greenhouse gases. The air bubbles trapped in ice cores provide a direct measurement of the concentration of gases like carbon dioxide and methane in the atmosphere at the time the ice was formed. These measurements reveal a strong correlation between greenhouse gas concentrations and global temperatures throughout Earth's history. This correlation is not just a coincidence. It's a fundamental relationship that underpins our understanding of the greenhouse effect. By studying the past, we can gain a clearer picture of how these gases influence our planet's climate and how human activities are altering this delicate balance. Now, let your mind wander to the remote and desolate locations where these ice cores are extracted. Imagine the logistical challenges involved in transporting massive drilling equipment to the heart of Antarctica or the summit of Greenland. Picture the dedicated teams of scientists and engineers working tirelessly in sub-zero temperatures, enduring harsh weather conditions and isolation, all in the pursuit of knowledge. These expeditions are not for the faint of heart. They require years of planning, meticulous preparation, and unwavering commitment. The data they collect is a testament to human ingenuity and our unyielding curiosity about the world around us. Reflect on the broader implications of paleoclimatology for our understanding of Earth systems. Ice core research is not just about reconstructing past climates. It's about understanding the complex interactions between the atmosphere, the oceans, the biosphere, and the cryosphere. These systems are all interconnected, and changes in one system can have cascading effects on the others. For example, changes in ocean currents can influence atmospheric temperatures, which in turn can affect the growth and decay of ice sheets. By studying these interactions, scientists can develop more comprehensive models of the Earth's climate system and better predict how it will respond to future changes. And as sleep gently pulls you under, consider the ethical responsibility that comes with this knowledge. The information gleaned from ice cores provides irrefutable evidence of the human impact on the Earth's climate. It paints a stark picture of the consequences of our actions and underscores the urgent need for action. We have a responsibility to future generations to protect the planet and mitigate the effects of climate change. The insights from ice core research can inform policy decisions and inspire individual actions that can help us create a more sustainable future. The story of the ice is a call to action, a reminder that we are all stewards of this planet and that our choices matter. Rest deeply, knowing that science is illuminating the path toward a more sustainable future, one ancient air bubble at a time. The beauty of ice core research also lies in its ability to connect us to the past in a very tangible way. Each layer of ice, each tiny air bubble, is a time capsule containing information about the Earth's environment at that specific moment. It's like holding a piece of history in your hand, a direct link to a world that existed thousands, even hundreds of thousands of years ago. Imagine the stories these ancient bubbles could tell if they could speak. Tales of volcanic eruptions that darkened the sky, of massive wildfires that raged across continents, of shifts in the Earth's orbit that triggered ice ages and warm periods. By analyzing the composition of these trapped gases and the properties of the ice itself, scientists can piece together a detailed picture of past climates and the forces that shaped them. Consider the incredible precision and detail that could be extracted from these frozen archives. Scientists can measure the concentrations of greenhouse gases like carbon dioxide and methane with remarkable accuracy, allowing them to reconstruct the history of these gases in the atmosphere over vast timescales. They can also analyze the isotopic composition of the ice, which provides valuable information about past temperatures. Heavier isotopes of oxygen and hydrogen tend to be more abundant in warmer periods, while lighter isotopes are more prevalent during colder periods. By measuring the ratio of these isotopes in different layers of ice, scientists can create a detailed temperature record that spans hundreds of millennia. Furthermore, the ice contains traces of other substances, such as volcanic ash, dust, and even microscopic organisms, all of which can provide clues about past environmental conditions. Think about the sheer scale of the undertaking involved in ice core research. Drilling through kilometers of ice requires specialized equipment, innovative techniques, and a deep understanding of glaciology. The ice cores themselves are incredibly fragile and must be handled with extreme care to avoid contamination or damage. Once extracted, the cores are transported to laboratories around the world, where they are subjected to a battery of sophisticated analyses. Scientists use a variety of techniques, including mass spectrometry, gas chromatography, and isotope analysis, to extract the information stored within the ice. The data generated by these analyses is then carefully compiled and interpreted to reconstruct past climates and understand the processes that drive climate change. It's a truly collaborative effort, involving scientists from many different disciplines and countries, all working together to unlock the secrets of the ice. And as you drift further into sleep, let your mind wander to the future. The knowledge gained from ice core research is not just about understanding the past. It's about preparing for the future. By studying past climate changes, scientists can gain valuable insights into the potential impacts of future warming and develop strategies to mitigate these impacts. Ice core data can be used to refine climate models, improve predictions of future sea level rise, and inform policy decisions related to greenhouse gas emissions. The story of the ice is a story of hope, a reminder that we have the power to understand and address the challenges of climate change. It is a story that emphasizes the importance of scientific research, international collaboration, and individual action in creating a more sustainable future for all. Let that knowledge soothe you and bring you peaceful dreams. And so, as we reflect on the profound insights gleaned from ancient ice, consider the ongoing discoveries and the relentless pursuit of knowledge that defines paleoclimatology. Scientists are constantly refining their techniques, developing new proxies, and expanding the geographical reach of ice core research. For example, researchers are now exploring ice cores from regions beyond Greenland and Antarctica, such as high-altitude glaciers in the Himalayas and the Andes, to obtain a more comprehensive picture of global climate variability. These ice cores can provide valuable information about regional climate patterns and the impacts of climate change on vulnerable ecosystems. Furthermore, advancements in technology are enabling scientists to analyze ice cores with unprecedented precision and detail. New analytical techniques, such as laser ablation inductively coupled plasma mass spectrometry, LHCPMS, allow for the rapid and high-resolution measurement of trace elements and isotopes in ice cores. This information can be used to reconstruct past volcanic eruptions, identify sources of pollution, and track changes in atmospheric circulation patterns. Similarly, the development of new dating methods, such as accelerator mass spectrometry, AMS, radiocarbon dating, is allowing scientists to more accurately determine the age of ice cores and the events recorded within them. Think about the implications of being able to precisely date and characterize past climate events. We can begin to understand the intricate relationships between different components of the Earth system, such as the atmosphere, oceans, and land surface. Ice core data, when combined with other paleoclimate record from sources like tree rings, lake sediments, and marine cores, can help us to reconstruct a more complete and nuanced picture of past climate variability. This information is crucial for understanding the natural drivers of climate change and for distinguishing between natural variability and human-induced warming. And as you gently breathe in and out, consider the inherent beauty and fragility of the Earth's climate system, so meticulously recorded within these icy archives. Each layer of ice, each tiny air bubble, each microscopic particle tells a story of a world in constant flux, a world shaped by complex interactions and feedback loops. By studying these stories, we can gain a deeper appreciation for the interconnectedness of the Earth system and the importance of preserving its delicate balance. The research isn't just limited to extracting and analyzing the ice itself. Scientists are also increasingly focused on modeling the processes that govern ice sheet dynamics and climate change. These models can be used to simulate the behavior of ice sheets under different climate scenarios and to project future sea level rise. By comparing model simulations with ice core data, scientists can refine their understanding of the processes that control ice sheet stability and improve the accuracy of their predictions. This is vital for coastal communities around the world, as they face the increasing threats of rising sea levels and coastal erosion. As you continue to relax, envision the vast, silent landscapes of Antarctica and Greenland, where these ice cores are carefully extracted. Picture the dedicated scientists working tirelessly in remote field camps, braving harsh conditions to collect these invaluable samples. Imagine the intricate laboratory analyses taking place in research institutions around the world, where scientists are meticulously piecing together the puzzle of Earth's climate history. It's a story of human ingenuity, perseverance, and a deep commitment to understanding our planet. And as you prepare to fully surrender to sleep, remember that the story of the ice is not yet complete. New discoveries are being made all the time, and there is still much that we don't understand about the Earth's climate system. But with continued research, collaboration, and a commitment to sustainability, we can unlock even more of the secrets hidden within the ice and create a brighter, more sustainable future for generations to come. Let the quiet wisdom of the ice soothe your mind and carry you into a peaceful slumber. Sleep well, knowing that you've learned something profound about our planet and our place within it. The ongoing research into paleoclimatology and ice core analysis extends beyond just understanding past climates. It also serves as a crucial baseline for evaluating the impact of human activities on the planet's current climate. By comparing pre-industrial climate conditions, as revealed by ancient ice, with the rapid changes we're observing today, scientists can more accurately attribute the causes of global warming and assess the effectiveness of mitigation strategies. This historical perspective is essential for informing policy decisions and guiding efforts to reduce greenhouse gas emissions. The ice acts as an irrefutable witness, silently recording the consequences of our actions and providing a clear warning about the potential for future climate disruptions. Furthermore, the study of ice cores offers valuable insights into the natural variability of the Earth's climate system. Climate is not a static entity. It fluctuates over time due to a complex interplay of factors, including changes in solar radiation, volcanic eruptions, and variations in Earth's orbit. Ice core records allow scientists to disentangle these natural variations from human-induced climate change, providing a more nuanced understanding of the forces that shape our planet's climate. This understanding is crucial for developing more accurate climate models and for predicting future climate trends. Consider the role of volcanic eruptions, for example. Ice cores preserve evidence of past volcanic events in the form of ash layers and sulfate aerosols. By analyzing these deposits, scientists can reconstruct the timing and magnitude of past eruptions and assess their impact on global climate. Large volcanic eruptions can inject vast quantities of sulfur dioxide into the stratosphere, where it forms sulfate aerosols that reflect sunlight back into space, leading to temporary cooling of the Earth's surface. Ice core records provide a detailed history of these volcanic cooling events, allowing scientists to better understand their role in the Earth's climate system. This knowledge is invaluable for predicting the potential climate impacts of future volcanic eruptions. The information gleaned from ice cores also extends to understanding changes in atmospheric composition beyond greenhouse gases. We can learn about past concentrations of aerosols, dust, and even trace metals. These components can influence the Earth's radiative balance and affect cloud formation, impacting regional and global climate patterns. For instance, dust particles can act as condensation nuclei, influencing the formation and properties of clouds. By studying the composition of dust trapped in ice cores, scientists can gain insights into past changes in atmospheric circulation patterns and land surface conditions. And as you drift further into a peaceful state, consider the collaborative nature of this scientific endeavor. Researchers from around the world, with diverse expertise in glaciology, climatology, chemistry, and physics, work together to analyze ice cores and interpret the data. It's a testament to the power of international cooperation in addressing global challenges. The insights gained from ice core research are shared openly and freely, contributing to a collective understanding of the Earth's climate system. So, as you continue to relax and allow sleep to wash over you, remember the profound story held within the ice. It's a story of our planet's past, present, and potential future. It's a story that reminds us of the interconnectedness of all things and the importance of protecting our shared environment. Let the weight of this knowledge settle gently upon you, reinforcing your connection to the Earth and inspiring a sense of responsibility for its well-being. Close your eyes, breathe deeply, and allow the quiet wisdom of the ice to guide you into a deep and restful sleep. Sweet dreams, knowing that even as you sleep, the story of the ice continues to unfold. The study of ice cores also provides crucial information about past climate variability, allowing scientists to distinguish between natural fluctuations and human-induced changes. By analyzing ice cores from different time periods, researchers can identify patterns and cycles in the Earth's climate system, such as the Milankovitch cycles, which are long-term variations in Earth's orbit that affect the amount of solar radiation reaching the planet. Understanding these natural cycles is essential for accurately assessing the impact of human activities on the climate. Ice cores also help us understand shorter-term climate events like El Niño and La Niña, and how their intensity and frequency may have changed over time. This historical perspective is invaluable for improving climate models and making more accurate predictions about future climate scenarios. Furthermore, the information locked within ice cores extends beyond the realm of climate science and offers insights into other fields, such as atmospheric chemistry and biogeochemistry. Ice cores can reveal information about past atmospheric deposition of pollutants, such as heavy metals and persistent organic pollutants. By studying the concentrations of these substances in ice layers from different time periods, scientists can reconstruct the history of industrial pollution and assess its impact on the environment. This information is crucial for understanding the long-term effects of pollution and for developing effective strategies for mitigating its impact. Ice cores can also provide information about past biological activity, such as the occurrence of algal blooms and the presence of microorganisms. These insights can help us understand how ecosystems have responded to past climate changes and how they might respond to future changes. And as you feel yourself becoming even more relaxed, consider the incredible logistical challenges involved in obtaining and analyzing ice cores. Drilling ice cores in remote and inhospitable locations, such as Antarctica and Greenland, requires specialized equipment and highly skilled personnel. The ice cores must be carefully transported and stored to prevent contamination and degradation. The analysis of ice cores is a painstaking process that requires sophisticated laboratory techniques and advanced data analysis methods. The dedication and expertise of the scientists involved in this research are truly remarkable. They brave extreme conditions and overcome numerous challenges to unlock the secrets of the ice and contribute to our understanding of the Earth's climate system. So, as you continue to breathe deeply and let go of any remaining tension, remember that each tiny air bubble within an ice core holds a piece of the Earth's history. It's a history that spans hundreds of thousands of years, a history that reveals the intricate workings of our planet's climate system, and a history that provides invaluable insights into our future. As you drift off to sleep, let the quiet wisdom of the ice fill your mind and inspire a sense of wonder and appreciation for the natural world. Know that even in your dreams, the story of the ice continues to unfold, revealing new secrets and offering new perspectives on our place in the universe. Sleep soundly, and may your dreams be filled with the peace and tranquility of the frozen landscapes that hold the key to understanding our planet's past and shaping its future. Sweet dreams, knowing that the Earth's ancient wisdom is always there, waiting to be discovered. And as you gently transition into deeper relaxation, let's consider the future. The study of ice cores isn't just about understanding the past. It's about predicting what might lie ahead. Climate models, the sophisticated tool scientists use to project future climate scenarios, are constantly being refined and validated using data from ice cores. By comparing the model outputs with the actual climate conditions recorded in the ice, scientists can improve the accuracy and reliability of these models. This allows for more informed decision-making about climate change mitigation and adaptation strategies. Imagine these ice cores as time capsules, whispering warnings and guidance from a past that is not so different from our present. They're helping us prepare for a future we can still influence. Think about the implications of this research. Understanding past climate variability helps us distinguish between natural climate fluctuations and human-induced changes. Ice core data has been instrumental in demonstrating the unprecedented rate of greenhouse gas increases in the atmosphere since the Industrial Revolution. This evidence strengthens the scientific consensus on anthropogenic climate change and underscores the urgency of reducing greenhouse gas emissions. It's a powerful reminder that our actions today will have profound consequences for future generations, consequences that will be etched, perhaps, in future layers of ice. Now, as you feel your body sinking deeper into your bed, let your mind wander to the sheer beauty of the ice itself. Imagine the crystalline structures, formed over millennia, each snowflake a tiny work of art. The ice is not just a passive recorder of climate. It's an active participant in the Earth's system. Ice sheets reflect sunlight back into space, helping to regulate global temperatures. They store vast quantities of fresh water, influencing sea levels and ocean currents. The melting of ice sheets and glaciers is a visible and alarming sign of climate change, and the study of ice cores helps us understand the processes driving this melting and its potential impacts. Picture the vast, silent landscapes of the polar regions, and know that these seemingly desolate places are teeming with scientific activity, driven by a desire to understand and protect our planet. And as sleep begins to gently pull you under, contemplate the international collaboration that is at the heart of ice core research. Scientists from all over the world work together, sharing data, expertise, and resources to unravel the mysteries of the ice. This collaboration transcends national borders and political differences, united by a common goal: to understand the Earth's climate system and to address the challenges of climate change. It's a testament to the power of scientific cooperation and the importance of working together to solve global problems. This shared effort is a beacon of hope, reminding us that even in the face of daunting challenges, humanity is capable of extraordinary cooperation and innovation. So, breathe deeply once more and let go of any lingering thoughts or worries. As you drift off to sleep, carry with you the image of the ancient ice, a silent witness to the Earth's history, a powerful tool for understanding our present, and a guide for shaping our future. Let the knowledge that dedicated scientists are working tirelessly to unlock the secrets of the ice bring you comfort and peace. Sleep well, knowing that the story of the ice continues and that you are part of that story. May your dreams be filled with the quiet beauty of the polar landscapes and the profound wisdom of the Earth's climate history. Sweet dreams, and may you awaken refreshed and inspired to learn more about the world around you. The ice awaits, and as your mind quiets, allow yourself to consider the sheer scale of the data contained within these icy archives. Each layer, each bubble, each trace element tells a story, not just of temperature and gas composition, but also of volcanic eruptions, solar activity, and even the impact of human activities over centuries. The science of interpreting this data is complex and multifaceted, requiring expertise in chemistry, physics, geology, and climate modeling. Scientists use sophisticated techniques to analyze the ice, employing mass spectrometers, gas chromatographs, and other high-tech instruments to extract the information locked within. Think about the painstaking process of dating the ice layers. Like rings in a tree, layers of ice accumulate over time, with each layer representing a year or even a season. By counting these layers and using radioactive dating techniques, scientists can establish a precise timeline, allowing them to correlate climate events recorded in the ice with historical records and other climate proxies, such as tree rings and sediment cores. This cross-validation of data is crucial for ensuring the accuracy and reliability of climate reconstructions. Imagine the challenges of drilling and retrieving ice cores from remote and inhospitable environments. Teams of scientists and engineers brave extreme cold, high winds, and logistical difficulties to access these valuable archives. They use specialized drilling rigs to extract long cylinders of ice, sometimes reaching depths of over 3 kilometers. These ice cores are then carefully packaged and transported to laboratories around the world, where they are analyzed and studied by researchers from diverse backgrounds. And as you feel yourself drifting further into slumber, consider the implications of ice core research for our understanding of future climate change. By studying past climate variability, scientists can gain insights into the processes that drive climate change and improve the accuracy of climate models. These models are used to project future climate scenarios and to inform policy decisions aimed at mitigating the impacts of climate change. The information gleaned from ice cores is not just about the past. It is also about the future, providing a critical foundation for building a more sustainable and resilient world. Let your thoughts now turn to the fragility of the polar regions and the urgent need to protect these vital ecosystems. The melting of ice sheets and glaciers is not just a scientific concern. It is a humanitarian crisis, threatening coastal communities, disrupting water resources, and impacting biodiversity. By understanding the causes and consequences of ice melt, we can take action to reduce our carbon footprint and to protect the planet for future generations. Each of us has a role to play in this effort, from making sustainable choices in our daily lives to advocating for policies that promote climate action. So, as your breath deepens and your body relaxes, embrace the knowledge that you are connected to the Earth's climate system and that your actions have an impact on the world around you. Let the story of the ice inspire you to be a steward of the planet, to protect its resources, and to work towards a more sustainable future. Close your eyes now and allow yourself to be carried away by the gentle rhythm of your breath. Sleep soundly, knowing that the secrets of the ice are being unlocked and that this knowledge is empowering us to address the challenges of climate change. May your dreams be peaceful and restorative, filled with the beauty and wonder of the natural world. Good night, and may you awaken with a renewed sense of purpose and hope. The ice whispers its wisdom, and it is time to listen as you drift further into slumber. Consider the immense time scale captured within these icy archives. Each layer, each bubble, represents a snapshot of a world vastly different from our own, yet intimately connected to it through the shared atmosphere and climate system. Think of the ancient civilizations that rose and fell while the ice was silently accumulating, preserving their atmospheric legacy for us to uncover millennia later. The Roman Empire, the dynasties of China, the Mayan civilization, all existed under skies whose composition is now etched in the polar ice. These are not just scientific records. They are echoes of human history, reminders of our fleeting presence on this planet and the enduring power of natural forces. Let your mind wander to the remote and pristine environments where ice cores are extracted. Imagine the dedication and meticulousness of the scientists who brave extreme conditions to collect these invaluable samples. They work in sub-zero temperatures, often for weeks or months at a time, carefully drilling into the ice sheet and extracting the core in sections. It's a labor of love, driven by a deep curiosity about the Earth's past and a commitment to understanding its future. These researchers are not just scientists. They are explorers, archivists, and interpreters of a frozen library that holds the key to our planet's climate history. Consider the intricate analysis that takes place in laboratories around the world, where ice cores are meticulously examined and analyzed. Scientists use sophisticated techniques to measure the concentration of greenhouse gases, such as carbon dioxide and methane, trapped in the air bubbles. They also analyze the isotopic composition of the ice itself, which provides information about past temperatures and precipitation patterns. This data is then used to reconstruct past climate conditions and to understand the natural variability of the Earth's climate system. It's a complex and painstaking process, but the rewards are immense, providing us with a detailed picture of how the climate has changed over hundreds of thousands of years. Now, envision the vastness of the polar ice sheets, stretching for miles in every direction. These ice sheets are not static. They're constantly moving and changing, responding to changes in temperature and precipitation. As the climate warms, the ice sheets are melting at an accelerated rate, contributing to sea level rise and altering ocean currents. The melting of the ice sheets is a stark reminder of the impact of human activities on the planet's climate system, and it underscores the urgent need to take action to reduce our carbon emissions. The fate of these icy landscapes is inextricably linked to our own, and their preservation is essential for the well-being of future generations. As you continue to relax, reflect on the power of scientific inquiry and the importance of international collaboration in addressing global challenges. The study of ice cores is a truly global effort involving scientists from many different countries and disciplines. They share their data and expertise, working together to unravel the mysteries of the Earth's climate history. This collaborative spirit is essential for tackling complex problems like climate change, which require a coordinated and sustained effort from all nations. Allow yourself to be soothed by the thought that even in the face of daunting challenges, there is reason for hope. The knowledge gained from ice core research is empowering us to make informed decisions about our future. By understanding the past, we can better predict the future and take action to mitigate the impacts of climate change. We have the tools and the knowledge to build a more sustainable and resilient world, and it is up to us to use them wisely. Let the gentle rhythm of your breath guide you deeper into sleep, carrying with it the wisdom of the ice. Imagine the earth breathing with you, a slow, steady rhythm that connects us all. The ice whispers its secrets, and in listening, we are becoming better stewards of this planet, our shared home. Sleep now, and dream of a future where humanity and nature coexist in harmony. A future where the lessons of the past guide us towards a more sustainable and equitable world. Good night, that As you drift further into slumber, consider the sheer scale of the ice sheets and glaciers that hold these climate archives. The Antarctic ice sheet, for instance, is the largest single mass of ice on Earth, containing about 61% of all the fresh water on the planet. If it were to melt completely, global sea levels would rise by approximately 58 meters. Greenland's ice sheet, while smaller, still holds enough water to raise sea levels by around 7 meters. These are not abstract numbers. They represent real and significant threats to coastal communities and ecosystems around the world. The ice cores extracted from these regions provide invaluable data for understanding how these ice sheets respond to changes in temperature and atmospheric composition, allowing scientists to refine their models and make more accurate predictions about future sea level rise. Think about the incredible journey of a single water molecule, originating perhaps as rain over the ocean, evaporating into the atmosphere, traveling thousands of miles on wind currents, and finally falling as snow on the polar ice cap. Over time, that snowflake is buried under layers of subsequent snowfall, compressed into glacial ice, and eventually becomes a tiny bubble of trapped air, a time capsule preserving a snapshot of the atmosphere from centuries or even millennia ago. That tiny bubble, when analyzed in a laboratory, can reveal the concentration of carbon dioxide, methane, and other greenhouse gases present at the time it was formed, providing a direct measure of the Earth's atmospheric composition in the past. This remarkable process, driven by the natural cycles of the Earth, is now under threat from human activities. Consider the dedication of the scientists who venture into these remote and challenging environments to collect ice cores. They brave extreme cold, high altitudes, and logistical complexities, driven by a passion for understanding our planet and a commitment to sharing their knowledge with the world. The process of drilling an ice core can take weeks or even months, requiring specialized equipment and a highly skilled team. Once extracted, the ice cores must be carefully preserved and transported to laboratories for analysis, where they are subjected to a battery of tests to unlock their secrets. These scientists are the unsung heroes of climate science, working tirelessly to provide the data we need to address one of the greatest challenges facing humanity. Now, as you approach the threshold of sleep, imagine the Earth as a complex and interconnected system, where every element is linked to every other. The atmosphere, the oceans, the land, and the ice sheets are all constantly interacting, influencing each other in subtle but profound ways. The study of ice cores allows us to see these connections more clearly, revealing the intricate web of relationships that govern our planet's climate. By understanding these relationships, we can better appreciate the fragility of the Earth's ecosystems and the importance of protecting them for future generations. Let the thought of this interconnectedness bring you peace, knowing that we are all part of something larger than ourselves, a global community working together to safeguard our shared home. Sleep soundly, knowing that even in your dreams, you are connected to the ancient wisdom of the ice, a silent witness to the Earth's enduring story. And as you drift further into slumber, Consider the sheer scale of time that these ice cores represent. Each layer, each bubble, a snapshot of a moment long past, stretching back hundreds of thousands of years. This is time on a geological scale, a perspective that dwarfs our own fleeting existence. It allows us to see beyond the immediate concerns of our daily lives and to appreciate the long-term consequences of our actions. The ice whispers tales of glacial advances and retreats, of volcanic eruptions that darken the skies, of subtle shifts in the Earth's orbit that trigger dramatic climate changes. It's a history book written in frozen water, a testament to the Earth's resilience and its capacity for change. Think about the implications of this knowledge for our future. By studying the past, we can gain valuable insights into the potential impacts of current climate change. We can see how the Earth responded to similar challenges in the past, and we can use this information to develop more effective strategies for mitigating the effects of climate change today. The ice cores are not just a record of the past. They are a guide to the future, a warning and a source of hope. They remind us that we have the power to shape our planet's destiny, but that we must act wisely and responsibly. Now, as your mind begins to quiet, imagine yourself standing on the vast expanse of an ice sheet, surrounded by nothing but snow and sky. Feel the biting wind on your face, the crunch of the snow beneath your feet, the profound silence that permeates the air. You are in a place of extreme beauty and fragility, a place that holds the key to understanding our planet's climate history. As you breathe in the crisp, cold air, imagine the ancient air bubbles rising from the depths of the ice, carrying with them the secrets of the past. Let these images fill your mind, transporting you to a place of peace and tranquility. And finally, as you surrender to sleep, remember that the story of the ice is not just a scientific one. It is a human one. It is a story of curiosity, dedication, and collaboration. It is a story of scientists working tirelessly to unravel the mysteries of our planet, of communities coming together to address the challenges of climate change, and of individuals making conscious choices to protect the environment. We are all part of this story, and we all have a role to play in shaping its ending. So sleep well, knowing that you are connected to the Earth's past, present, and future, and that your actions can make a difference. Let the gentle rhythm of your breath lull you into a deep and restful sleep, filled with dreams of ice and snow, of science and discovery, and of a brighter future for our planet. Good night, as you drift further into slumber. Consider the sheer scale of the ice sheets themselves. Imagine the Greenland ice sheet, a vast, frozen landscape covering an area nearly 3 times the size of Texas. Beneath its icy surface lies a record spanning over 100,000 years. Or picture the Antarctic ice sheet, an even more immense reservoir of frozen water, holding clues to climate changes stretching back over 1 million years. These are not static, unchanging entities. They are dynamic systems, constantly responding to shifts in temperature, precipitation, and atmospheric conditions. The ice flows, albeit slowly, carving valleys and shaping the landscape beneath. The surface melts and refreezes, creating intricate patterns of ice and snow. And within this dynamic environment, the air bubbles remain trapped, preserving their precious cargo of ancient air. Think about the incredible technology and human ingenuity that allows us to unlock the secrets held within these ice cores. From the massive drilling rigs that bore deep into the ice, to the sophisticated laboratories where the ice is analyzed, every step of the process is a testament to our scientific curiosity and our determination to understand the workings of our planet. Consider the meticulous care with which the ice cores are handled, each section carefully labeled and preserved to prevent contamination. Imagine the scientists working in cold, sterile environments, painstakingly analyzing the air bubbles, measuring the levels of greenhouse gases, and piecing together the puzzle of Earth's climate history. It's a delicate and demanding process, but the rewards are immense. And as you breathe deeply, let's delve a little deeper into the science itself. The gases trapped within the ice bubbles are not the only source of information. The ice itself holds valuable clues. The isotopic composition of the water molecules, for example, reveals information about past temperatures. Heavier isotopes, like oxygen-18, are more prevalent in warmer periods, while lighter isotopes, like oxygen-16, are more abundant in colder periods. By analyzing the ratio of these isotopes, scientists can reconstruct past temperature fluctuations with remarkable accuracy. Dust particles trapped in the ice can also provide insights into past volcanic activity and wind patterns. Layers of volcanic ash can be used to date the ice cores, providing a timeline for climate events. And the presence of certain chemicals, such as sulfates and nitrates, can reveal information about past pollution levels. Think about the implications of this research for our understanding of climate change today. The ice cores provide irrefutable evidence that the Earth's climate has changed dramatically in the past, and that these changes can have profound impacts on ecosystems and human societies. They also show that the current rate of climate change is unprecedented in at least the last 800,000 years, and that human activities are the primary driver of this change. By studying the past, we can better understand the potential consequences of our actions today, and we can develop more effective strategies for mitigating the effects of climate change. We can learn from the successes and failures of past civilizations, and we can make informed decisions about our future. Now, as your thoughts begin to fade, picture the future. Imagine a world where we have successfully transitioned to a sustainable energy system, where we have reduced our greenhouse gas emissions to near zero, and where we are living in harmony with nature. Imagine a world where the ice sheets are stable and healthy, where sea levels are not rising, and where ecosystems are thriving. This is not just a dream. It is a possibility, but it requires action. It requires us to embrace science, to invest in renewable energy, and to make conscious choices about our consumption patterns. It requires us to work together as individuals, communities, and nations to address the challenges of climate change. So, as you finally drift off to sleep, remember the story of the ice. Remember the ancient air bubbles, the frozen landscapes, and the dedicated scientists who are working to unlock their secrets. Remember the lessons of the past, the challenges of the present, and the possibilities of the future. And remember that you are part of this story and that you have the power to make a difference. Sleep soundly, knowing that you are connected to the Earth's climate history and that your actions can help to shape a brighter future for our planet. Let the gentle rhythm of your breath carry you away into a deep and restful sleep, filled with dreams of ice and snow, of science and hope, and of a sustainable future for all. Good night and sweet dreams. Now let your mind wander a bit further beyond the immediate actions we can take. Consider the beauty and complexity of the Earth system itself. Think of the intricate dance between the atmosphere, the oceans, the land, and the ice. Each element is interconnected, each influencing the others in profound ways. The ice cores are not just records of the past. They're pieces of a puzzle that helps us understand how this intricate system functions. They reveal the delicate balance that sustains life on our planet and the potential consequences of disrupting that balance. Think about the power of feedback loops, how small changes in one part of the system can trigger larger changes elsewhere. For instance, as the Arctic ice melts, it exposes darker ocean water, which absorbs more sunlight, leading to further warming and more melting. This is a positive feedback loop, accelerating the process of climate change. Understanding these feedback loops is crucial for predicting the future and for developing effective strategies to mitigate climate change. The ice cores provide invaluable data for modeling these complex interactions and for improving our understanding of the Earth system as a whole. Consider also the ethical dimensions of climate change. We have a responsibility to future generations to leave them a planet that is habitable and thriving. The choices we make today will determine the fate of those who come after us. The ice cores remind us that we are part of a long chain of human history and that we have a moral obligation to protect the environment for those who will inherit it. This is not just about science. It is about values, about justice, and about our shared humanity. We must act with courage, with compassion, and with a deep sense of responsibility to safeguard the future of our planet. And as you continue to relax, think about the power of human ingenuity and innovation. We have the knowledge, the technology, and the resources to address the challenges of climate change. We can develop new sources of clean energy, we can improve our energy efficiency, and we can create more sustainable ways of living. The ice cores can even inform these technological advancements by revealing the climate conditions under which past civilizations thrived or collapsed. By learning from the past, we can build a more resilient and sustainable future. We can harness the power of science and technology to create a world that is both prosperous and environmentally sound. Finally, let your thoughts settle on the feeling of hope. Despite the challenges we face, there is reason to be optimistic. We have made progress in understanding climate change, and we are developing new solutions. More and more people are becoming aware of the issue and are taking action. Governments, businesses, and individuals are all working together to address climate change. The ice cores are a testament to the power of scientific inquiry and the ability of humans to understand and solve complex problems. By working together, we can create a brighter future for ourselves and for generations to come. So, breathe deeply and let the images of glaciers and ice sheets, of scientists and laboratories, of past climates and future possibilities fade into the background of your mind. Let the gentle rhythm of your breathing lull you into a state of deep relaxation. Know that you are part of something bigger than yourself, that you are connected to the Earth's climate history, and that you have the power to make a difference. Allow yourself to drift off to sleep, filled with a sense of peace, of hope, and of connection to the natural world. Sweet dreams, and may your sleep be as deep and as restorative as the ancient ice itself. As you gently transition towards sleep, consider the profound implications of paleoclimatology, not just for understanding our past, but for predicting our future. The data locked within these icy archives isn't merely a historical record. It's a sophisticated model, a natural experiment played out over millennia. Scientists use this data to calibrate and refine climate models, the very tools we rely on to project the impacts of future warming. The more accurately we can reconstruct past climates, the more confidence we can have in these predictive models. Think of it as tuning a complex musical instrument. The ice cores provide the notes, the melodies of Earth's past climate symphony. By listening closely, we can adjust our models to better reflect the real-world complexities of the climate system. These models, informed by the echoes of ancient atmospheres, help us understand the intricate feedback loops that govern our planet's climate. For instance, the concentration of greenhouse gases in the atmosphere affects global temperatures, which in turn influences the extent of ice cover. Ice, being highly reflective, bounces solar radiation back into space, helping to cool the planet. As ice melts, this reflectivity decreases, leading to further warming, a positive feedback loop. The ice cores allow us to quantify these relationships, to understand the magnitude of these feedbacks, and to incorporate them into our climate projections. This is crucial for anticipating the speed and scale of future climate change. Furthermore, the study of ice cores offers invaluable insights into natural climate variability. The Earth's climate has always fluctuated, driven by factors such as changes in solar activity, volcanic eruptions, and variations in Earth's orbit. By examining the ice core record, we can disentangle these natural variations from the human-caused changes that are now dominating the climate system. This is essential for accurately attributing climate change and for developing effective mitigation strategies. It's like listening to a complex piece of music and being able to distinguish the different instruments, the different melodies, and the overall composition. By understanding the natural rhythms of the Earth's climate, we can better discern the human-induced changes that are disrupting the harmony. Now, imagine the dedication and precision required to extract and analyze these precious ice cores. Teams of scientists from around the world collaborate on these projects. Enduring harsh conditions and logistical challenges, to unlock the secrets held within the ice. They meticulously drill into the ice sheets, extracting long cylinders of ice that can stretch for kilometers. These cores are then carefully transported to laboratories, where they are analyzed using a range of sophisticated techniques. From measuring the concentrations of greenhouse gases trapped in air bubbles to analyzing the isotopic composition of the ice itself, every measurement provides a piece of the puzzle. It's a testament to human curiosity and our unwavering pursuit of knowledge. A quiet, persistent quest to understand our place in the universe and to protect the delicate balance of our planet. As you continue to relax, let your mind wander to the vast, pristine landscapes where these ice cores are collected. Picture the remote research stations, the dedicated scientists, and the silent, ancient ice sheets stretching towards the horizon. Feel the cold, crisp air, the weight of history, and the profound sense of connection to the Earth's past. These are places where time seems to stand still, where the secrets of the planet are slowly revealed. And know that, even as you drift off to sleep, the work of understanding our climate continues, driven by the power of human curiosity and the urgency of our times. Let the quiet wisdom of the ice guide your dreams, and may your sleep be filled with the promise of a sustainable future. Good night. Now, as we contemplate these icy archives, let's delve a little deeper into some of the specific insights they've provided. For instance, ice cores have been instrumental in reconstructing past temperature fluctuations. By analyzing the ratio of different isotopes of oxygen and hydrogen within the ice molecules, scientists can determine the temperature at the time the snow originally fell. Heavier isotopes tend to condense more readily in warmer temperatures, so their abundance in the ice provides a direct proxy for past climate conditions. This isotopic analysis has allowed us to create detailed temperature records stretching back hundreds of thousands of years, revealing the natural cycles of glacial and interglacial periods that have shaped our planet. Furthermore, ice cores have allowed us to precisely correlate greenhouse gas concentrations with temperature changes. The trapped air bubbles within the ice act as time capsules, preserving samples of the ancient atmosphere. By measuring the concentrations of gases like carbon dioxide and methane, scientists can directly compare these levels with the temperature records derived from isotopic analysis. The results are striking. There's an incredibly strong correlation between greenhouse gas concentrations and global temperatures throughout Earth's history. This provides compelling evidence that greenhouse gases play a critical role in regulating our planet's climate. And, crucially, it provides a clear benchmark against which to measure the unprecedented increase in greenhouse gas concentrations we're experiencing today due to human activities. Beyond temperature and greenhouse gases, ice cores also offer insights into past volcanic activity. Volcanic eruptions can inject large amounts of aerosols and dust into the atmosphere, which can temporarily cool the planet by reflecting sunlight back into space. These volcanic aerosols leave a distinct chemical signature in the ice, allowing scientists to identify and date past eruptions. By studying the timing and magnitude of these eruptions, we can better understand their impact on climate and their role in natural climate variability. In fact, some particularly large volcanic events are clearly visible in ice core records from around the globe, providing a synchronized marker for dating and correlating climate events across different regions. But the story told by ice cores isn't just about the big picture of global climate change. They also provide valuable information about regional climate patterns and environmental conditions. For example, ice cores from Greenland can reveal changes in precipitation patterns, storm frequency, and even the sources of atmospheric pollutants. By analyzing the chemical composition of the ice, scientists can track the origins of dust and aerosols, providing insights into past wind patterns and the transport of pollutants across continents. This regional perspective is crucial for understanding the complex interplay of factors that shape local climates and ecosystems. Think about the implications of this knowledge. Imagine being able to reconstruct the environmental history of a particular region, understanding how it has responded to past climate changes, and using that information to predict its vulnerability to future changes. This is precisely what ice core research makes possible. It provides a powerful tool for informing conservation efforts, managing water resources, and adapting to the challenges of a changing climate. It's about understanding the specific vulnerabilities of different regions and developing tailored strategies to protect them. And so, as you continue to relax and prepare for sleep, consider the quiet power of these frozen archives. They are a testament to the enduring power of scientific curiosity and the unwavering pursuit of knowledge. They are a reminder that the Earth has a long and complex history, and that understanding this history is essential for navigating the challenges of the future. Let the wisdom of the ice inspire you to think about the long-term consequences of our actions and to embrace the responsibility of protecting our planet for future generations. Let the silence of the ice fill your mind with peace, and may your dreams be filled with the hope of a sustainable and harmonious future. Sleep well.